chart development process is being used in the Casa Grande plant. What you can see here are some people laying out the control charts. What I'd like to do is just to take a quick walkthrough to try to explain more or less what's on these charts, how it was developed, and what will be used, what it will be used for after it's all over with. Represent the overall process of this particular oil of making potato chips, or the process for making corn products. Represents the incoming materials or products, and the outgoing arrow represents the outgoing products. The product itself represents a sort of a conversion step, conversion process. Here, the process will begin with the weighing scales. From there, it will move into actually dumping or unloading trucks. And then the next stage would be storing, unloading oil into storage. The next stage would be moving it again into storage. As you move on down to each of the boxes represents a step in the overall process of converting potatoes and potato feed out, primarily to increase the ability to control the variables that can have a negative influence on the quality of the product, the cost of the product, the throughput, or any other aspect of the conversion process. The approach to doing the analysis starts off with establishing what is the specification. In this particular case here we have cottonseed oil coming in with a key spec of no more than 800% free fatty acids. Under the arrow on oil and rail car, we take a look at what are the variables that actually do occur. We do have variations in free fatty acids, for example. We have variances in the type of oil, whether it be cottonseed or soybean. We have variations in the peroxide values of the oil, the foreign material in the oil, and the preservatives in the oil. So the first step in variance analysis is to identify the key variables that can affect the successful process. In storage, there are certain things that happen to it. Again, you can have processing variances such as the amount of oil in the storage, the amount of recirculation that is given to oil, the temperature of the oil in the storage, the amount of spoilage that may have occurred, spills, moisture, things like that that can happen to that part. From an equipment standpoint, you can have variations in whether or not the pumps are working, whether the hoses are damaged, whether there are broke or leaking pipes, whether there are tank leaks. You can have frozen valves, steam leaks, many significant equipment variances. The stars represent what are called key variances, and these are variances that 20% of the variances cause 80% of the equipment problems. That's what's roughly the definition of the key variance. After the storage stage, what happens is the sum total of the processing the equipment variances leads to the potential for other variations being created, such as a certain amount of dirt being injected into the oil, or perhaps some rancidity developing in the oil. Now, the spec we're looking for, however, is clean, usable oil for the frying process. See, here we've got potatoes moving into bin storage. These are coming in, they're on conveyors. There are variations in the material itself, such as the wet breakdown in potatoes, foreign material, there could be sand or rocks, there could be sprouts, many defects on the raw material itself. As you look at the processing variances, the rotation of the potatoes, the overfilling of bins, the mixing of potatoes in the wrong bins, or equipment variances such as conveyors that are not operating properly, improper lighting systems, electrical system breakdowns, those kind of variances, which then on the output side can cause damage to the potatoes, can cause changes in sugar or starch content, you can get some rodent infestation. These are some of the variances on the output side. Similar chart, in this particular case, however, we're dealing with corn products. In the beginning, you see corn coming in rail cars, and you're receiving storage and transport conversion process. Same as above, try to list what you call the ideal specifications, what you're trying to look for. And below the barrel there, you see the actual variances that are being developed as you move, as you come into this process. Same thing here. Here are the major processing variances that can have an effect on quality or cost, throughput. And here are the major equipment variances that can have an effect on quality, cost, or throughput. Then Carrying on through there, so we get into the raw tested corn, and the output side is where the major variables that can be transferred from the boundary of this particular processing step to that next processing step, which is raw corn cleaning. Analysis has been done. The next step is to try to identify the interdependencies between the various variables that occur in that overall processing scheme. This is normally done by constructing what's called a variance matrix. What you would see here are some people in the process beginning to examine interdependencies between each of those variables, how one variable will affect another variable, and through that mechanism try to determine what kind of control mechanism that can be established or put in place in order to avoid those variances transferring on into later stages of the system and causing troubles. Constructed for use in doing the interdependency analysis using this variance matrix on the corn processing. Now, the technique that's being used here is to start off with material variances such as cracked and broken pieces of corn, corn material, color, and so forth. List those as incoming variances, and then move in listing some processing variances that are key, such as the rate of delivery, the sanitation of the equipment, and then maybe some equipment variances such as failure of the drag conveyor or bucket elevators that aren't working properly. From there, the next stage that they'll be working on is to actually say, where does cracked and broken pieces affect some of these later stages of processing? And that'll be the next step of completing what's called a variance matrix, which will indicate the interdependencies between the variances from the very beginning of the process, which is the corn receiving, to the very end of the process, which in this particular case would be the corn processing, and then it'll be same thing.
We going into as far as variances and controls was to set up, first of all, was to set up a flow chart of the different corn units processes going through the corn unit hardness.
These variances
become a resource. If a group would like to come here and ask to help them construct this, you think eventually down the line, yes, there would be.
the key ones, and then the other ones were just, did we leave any major ones out, or did we pick the one that we thought was major that's really not important to that area?
One question I have was in this corn cleaning area. We needed some specs for basically the equipment, RPMs, or I guess
How do you know it's clean? You know, touch it, feel it,
yeah.
squeaky.
What exactly are we looking at for steps? What's the rate of the run, pounds per hour, strength there?
Some traditional equipment cleaner is probably some of that, but it's beautiful. You grab it, it's more visual, especially this one per se.
So CMB would be visual.
Well, you can actually count the crack and broken.
Okay.
Yeah, and that's one of the quality control things. I guess what he's asking too is the specification of throughput. Part of day, what would that be? How do we set up part of day? How do we go through that?
Cleaning operation, that's mainly to take out some of those fines and some of the larger kernels, larger and smaller kernels. The actual crack and broken, not the operation, sizing and removal of the interior.
This won't be that precise. Take this extra, just look at key variances. Let's key on those and see if we can pick out any others. See if we can estimate of the key variances in the operation. Yeah.
Yeah, because I think that it's a valuable tool, but the key piece is what are we going to use it for? Are we going to go and look at getting some equipment modifications to eliminate cracked and broken? Are we going to install a new test there, like a quality test, to make sure that we're eliminating that and have a control point to give us 100% quality down the other side of it?
Another thing we could do is at some point, conventional plants, we're testing the things down in the process when we really should be testing earlier on. So we're trying to figure out how might we test for things earlier on. Also, we're seeing interdependence of these, and that's the next step is how is cracked and broken here independent with each of the areas. Plus, we identified a lot of variances, and then what's going through our minds are how might we reduce that variance or eliminate it so that we don't have to worry about it. So it's more of a tracking and then improving our process.
Cracked and broken, poor material, and possibly hardness, which is tested. We have not, excessive hardness is not a test we have. For process variances, we had rate or pounds per hour, and then
We learned that from yesterday. I guess we overloaded the system and it.
your equipment variance would be falling into two areas. You have your drag conveyor and then your bucket elevator.
And we felt that they were the most crucial. The other ones we probably could work around or get a replacement in very quickly.
Right.
I think I'd make one suggestion on the incoming corn as far as a key variance, where unless you're including insects in corn matter, they probably need to be listed as a key variance.
Key variance.
And they can shut the whole process down right there.
This goes back up to the specs here. We had evidence of rodents, insects, mold, appetites.
Problem is though,
It would be a key variance.
Okay, you're including that in corn material?
Yes. Okay. We did discuss that.
Okay.
The hardness you're referring back to is that you want on the plant with the corn, I mean, that maybe like you got it parked out, elements.
You want to mix those in?
To give you a feel for how the variance analysis process itself starts off. So looking at each of the variables at each stage, what's the impact of that variable on the overall processing of the equipment, on the material, on quality, on cost, on throughput, and anything else. This particular group will continue on for some time, exploring the significance of each of those key variances and how they may impact the process and what kind of improvements could be instituted, either of analytical techniques and detection points and of course the equipment itself and even the raw materials. What kind of improvements would be needed to improve the overall effectiveness?
What we'd like to do here is take a few of these material variances that we have, like on corn receiving, like cracked and broken, take it down through our matrix here and find key points where, number one here, cracked and broken, will make a difference in the process. And I'd like to get some feedback from you all on where this would have some effect or some variance on the process. So here again, you're going to have cracked and broken corn picking. And so forth. So starting off with, let's say, cleaning, where will the cracked and broken have to be, if at all? Okay, into the corn pick, cracked and broken.
It depends, it also depends, the level does depend on the rate. You can't clean that corn, how much of that material you want to remove. There's an issue there on yield. You want the lowest cracked and broken coming in, but you don't necessarily want to remove it all because of the cost restraint on producing material. You want to clean it to that point where it's acceptable that you can process quality product.
So your rate of cleaning or the yield out of it would be effective. So that would be like the one quick category. Okay, into the picking now, we have cracked and broken falling out. What would be a process or possibly a quick?
You're cracked and broken, and you go from one over to the other, it would affect your cook time. Because they would make it stick them up, or you'd overcook it or undercook it possibly.
So you're looking at possibly the dwell time.
Sam, would that temperature of the water or the corn cause any cracking or breaking? Would it affect it in any way?
It would affect it more. You talking about cooking right here or what?
Cooking,
The
right? Cooking.
temperature, yeah, on
You
the...
talking about the temperature of the cook water?
Of the cooking.
Yes, it will affect the cracking.
Temperature of the corn and
So that would have an effect on the crack and broken.
It'll have an effect on your pH too.
Is that the cracked and broken affecting cooking and pH? It affects both of them. Okay.
so these three processes here, cooking, crack, and broken.
Affect all of those?
That's the whole idea of lowering your temperature in our cook system to 195 versus boiling.
Okay, now we're coming down into the soak area. What we're looking at now is a variance is exploding corn, which is the result of crack. So,
This is a real aid for training. Sam Hall, the person who's making the presentation, is a technician new to the company, hired on, I think, the 29th of May. Here it is, less than a month, able to lead a group through this kind of analysis. The people in the audience represent some management people, some professional people. Steve is from the corporate analytical group. Some of the other people, Leon is from the potato chip area, running technology for use there. Andy is from the plant concerned with quality assurance. So the thing we're trying to illustrate here is the utility of this particular technique in helping people learn from each other about the significant aspects of the system, and variances in the system can impact the overall system.
You're talking about exposed corn, that's just not proper storage of rubber.
okay, what effect would that have?
What effect would that have? You have improper moisture pick up in the corn, it helps remove the wood being settled. You have hot spots.
Pretty obviously, this gives a good reading on cause-effect relationship. In some cases, cracked and broken material variances cause a processing problem, such as the throughput or the rate of flow. In other cases, the equipment, such as the conveyors, can cause a material problem, such as cracked and broken. In other cases, the processing variances can cause a material problem, such as the overcooking can cause a massive